Hi, my name is Anshuman Dash, and I'm a third year student. My pronouns are he, him, his, and I'm applying to be a CSLA. So, the reason why I'm applying is I really love teaching and tutoring. I used to tutor professionally, mostly for CS and math, stuff like that, and I'd also tutor my friends in the CS courses, and that's a big way of how I learn and how I kind of study. But a big reason why I want to TA, especially for these CS classes, is I do think that CS is an incredibly daunting field, and it's one of those things, if you fall behind, it's very hard to catch back up. And it can feel really overwhelming because it's completely new. Most people, if they don't know coding before, it's a really daunting field. So being able to help with those fundamentals really does make the entire process a lot easier. So I want to tutor for CS, mostly the courses under 40, but I'm fine with the other courses also. But these are mostly like the fundamental courses where it's really important that they have a good kind of understanding of this. All right, so for my kind of tutorial, I'm going to be kind of covering compilers because I know that when I took the course, a lot of kids were confused about it and we would just use makefiles and we didn't understand what it was. So here. All right, so the first example that I have here is basically just a clean basic file. So if we go into this thing, so we can cd into the directory, and it's just makefile. So there's three ways you can kind of start to compile this. So we can start off by just gccing and the main.cpp file. And since it has everything it needs, it'll create an a.out file. And we can run this a.out and it'll give us the output. And another thing we can do, a really useful flag that you'll use pretty much every time, is dash lowercase o, which is the output. If I do main, it'll compile that to something called main that we can see right here. If I run this, we see it here. And just for kind of small projects, simple just stuff, if you don't have a make file and it's just a single file kind of thing, you can do, so let me just clear that. If I do make main, the name of the file without the CPP, it'll also run that same command for me. So that's just the basic way of doing that. Now onto the next example. So here, let's say that I have a header file and I have a main file. So what this is saying is basically, when I put this include, you can just think, I'm just taking this entire file and just dragging and moving it wherever this include is. And so one thing to notice is see how I'm doing cout endl without including iostream or namespace std. Because since these have been defined before, it's pretty much the same as me just doing this. And so if I go into here and I do g++ main.cpp, no other files, and I output it as main, it compiles fine and it runs. And the reason why is because this basically just gets copied in, so it looks like it's just one file. It doesn't have any dependencies. If I look at the third example here, so now, let me quickly. All right, so here, if I go here, I have three files. So I have a file bark and I have a file meow. Both of these write something for the speak function. And here in the main file, I basically just do this, which is saying, hey, here's a function. I'm not going to define it yet, but this is what the function looks like. So the compiler knows what to do. So now, if I go into this folder and I'll do g++, I'm going to add the -c flag. What this does is it compiles it, but it doesn't link it together. And I'll explain what that is. So if I compile my main.cpp, bark.cpp, and meow.cpp, just to save time, we can see here that we have our bark.o, our meow.o, and main.o. These are our object files. This is basically just compiling the code, but I'm not stitching it all together, telling it, oh, this function actually points here, all this stuff. So now if I go g++ and I give it the main o file, and I give it, let's say, the bark o file, and name it barking. So now what this does is it's basically saying, hey, take these two files together and just stitch them together. Make that one project and link those things together. So now the speak is going to point to this speak. And now let me quickly do this for the cat meow file also. And so now we have, if I do ls, we can see meowing and barking. If I run meowing, we see that it prints out this print statement when it goes and calls speak. If I call barking, it does woof. So even though this main file is the exact same, it'll do both of these. Let me go to the example 4 file. I'm kind of running out of time. So here, this is going to be a common use case. Basically, most of the time for your projects, you'll be having a header file and a C++ file, CPP. And what that's basically saying is the header file is kind of explaining, hey, this is the content that this kind of thing is going to have, but it doesn't define it. And then the CPP file is saying, oh, this is what all of those things do. So it seems a little bit convoluted, but so the reason why we have this is here. I can add our header guards, which is basically telling the compiler like, hey, only include this once. And I can cover that another time. But so here in our main file, I include the header. So if I go into here and I do g++ main.cpp and I just try to compile it, it's going to throw me an error because it says it doesn't actually know this function, which gets defined in something else. So to do these, you can either, so just to save time, I'm going to do both steps at once. I'm going to compile both of those files together and output it to main. And now, if we look at this, our square number is defined here, which we compiled at the same time, and they get linked together so that it actually can call that function. And see, we have 5 squared is 25. And finally, for example 5, I'm going to show you some useful things that aren't really covered in classes. So if I just go main.cpp o main, so it just compiles, right? But first of all, if I just do, so I'm going to call time, which is a Linux command. And so if I run the main file, we see we kind of do a ton of kind of computation and it takes 2.5 seconds. So one thing I can do to speed this up is I'm going to add the -03 flag and I'm going to call this optimized. So I can add anything here from 01 to 3 and also fast, but just 03 is good enough for pretty much anything. And what this will do is it'll optimize your code for you. It'll basically go through, and now look, if I time it, so if I time this, it pretty much instantly finishes. This is like 1,000 times faster because what it's doing is it's basically saying, hey, if you actually look at the assembly for what this compiles to, it's saying, hey, this entire loop doesn't actually matter. The only thing we're changing is R1, but we're returning R5. And so it will just completely get rid of this. And it'll do a ton of like optimizations for you, like not even just trivial things. So if you want your code to run faster, it usually doesn't hurt. And another very useful thing is warnings. So C++ very much has a lot of little intricacies. And so if I compile this with the warnings flag, look at this. So it tells me here, oh, unused variable. I never used this variable. I accidentally left it in there. It tells me, oh, look, array subscript is above array bounds. Basically saying, hey, look. So the array has up to 5 things, meaning it can index at 0 up to 4, but I'm accessing it at 5, which is out of bounds. C++ will let you do it, but now what WALL is basically warnings all. It'll turn on all the warnings. And so highly recommend. It will save you time on debugging and help you understand your stuff better. I'm over the 5 minutes, so I'm going to stop this here, but I really hope I can help tutor. Thank you.